Welcome back, generals, to another Let's Fix Generals 0 hour to make the best game ever. Okay, so there is a change work in progress here, a model file converter by QEL. It's a work in progress, so nothing to review yet. I already briefly looked over the code. I didn't yet read this. What is this? Implemented functionality convert binary W3D for text-based. Okay, well, it's not yet done, but work in progress. File structure, replicated the file structure and user input flow. Developed the necessary data structures to support the conversion process. Implemented functions for reading and handling W3D files. Yeah. So there are a bunch of files in this review which belong to the game text compiler change, yeah, which has not been merged into any main branch. Maybe we should create a new branch and call it like, I don't know, tools development, something like this, and then we just like implement all the tools on there, which is I mean, or we move it all to super hackers / super Thyme. And then have a separate branch there, because eventually we will branch off core Thyme anyway, because there likely will be a few things here and there which will be different from core Thyme. But on the other hand, it would be good to get the core tools into Thyme. But on the other hand, they are third-party tools here. They are not original ones. Yeah, no, I don't know yet. But it's okay. As long as we have then one branch where everything just works, it's fine. Okay, so it's down here, game model converter. I think he did not touch any W3D code in engine. It's just this tool, right? Yeah. By the way, I think in the tool it's not necessary to use array, because there you can use std array actually. Many of these, like array, was only added because a game engine uses STL port, an old version, and there it cannot use the latest STD. That's why a bunch of these things were added. Yeah. Okay, but that's beside the point. Yeah. Okay, so basically there is a read W3D file, chunks, and write. Pass model data, mesh chunk, emitter chunk. Yeah. I'm actually wondering, like, I'm not sure if this tool can handle this Blender and Max, because I would have thought that this tool would just convert between W3D and W3X, but not Blender and Max. I guess it could, but yeah, I don't know. Maybe. Because the Blender, so in the mod builder it already has implementation for exporting W3D to blend, but not the other way around, because because you don't, we don't yet generate blend files from W3D through mod builder. I don't know. It probably needs to be done. Maybe, yeah. I don't know. Okay, but the core of this is these two files, right? W3D and the plain text XML format. Yeah. Okay, I don't know where this comes from here. It's probably copied from engine somewhere, I guess. Yeah. Read subchunks. So read W3D. It's in here. File ref. Read 3D chunks. Read from chunk. Read from chunk. Offset plus size of T. Offsets. Yeah. I'm a bit surprised about this check. I would have thought that it should be size times size of T bigger than something, num elements. I'm not sure. Num elements. Hmm. Hmm. Chunk info. Read array from chunk data. What is this data? Raw chunk data. Hmm. Yeah. So how's this reading and writing work right now? Read chunks. Here. Wire true. Chunk information chunk. Data, current position. Subchunks. Hmm. Hmm. Bright chunks. I, I think MSB means most significant bit, but I think it's a strange abbreviation. Like it's not intuitive, so yeah, I personally wouldn't write it like this. Hmm. Okay, so basically it's just writing the chunks raw as they are. Yeah. But but hold on. So this chunk infos, what is it? Chunk infos. Chunk infos. Here, chunk info. Subchunks. data. Okay, so I guess this is the I'm not yet. Can we see? Let's open Thyme. I mean, chunk is one thing, but you still need to understand everything that is inside those chunks. What do these chunks describe, right? So it looks like to me, like I think the model converter needs to have full knowledge over all the chunks, what it all means, right? Because essentially you need to write every little thing and need to read every little thing from the XML and write it into the binary data and vice versa, right? So it needs to have full understanding. And for this, so there is a W3D file .h. So and that contains all the chunk information. And it's a lot. It is a whole lot of information in there. So there are all these structures here. I don't recall where file is loaded. Maybe we can. Well, we can search for like the struct for or this one. Let's search for this. wdump. Read chunk data. What is this doing? cload, chunk load class. There we go. File class. So this one, what is it? W3D lib chunk IO. There we go. Chunk IO. Is this all? Chunk format reader. This class handles reading from a binary chunk format as used by various binary file formats. Yeah. Oh, there's also a save class. Look at that. Huh. Format writer. Huh, I didn't know. Micro chunk header, I don't know what that is. Chunk header. Sub chunk flag. Yeah. So from my understanding, the converter tool should reuse as much as possible from this stuff here. I find it to be very convenient that there is a save class. Is it implemented? Yeah. Wow. Yeah. I would highly recommend to start looking here. It also has a sub chunk flag thingy here, which we have seen in the code. So I think it should try to reuse as much as possible from here, from original game, right? So here, chunk load class. Let's see how this is used. Load 3D assets. Pass subchunks. Yeah. Load 3D assets. Chunk ID. Compress animation, morph animation, hierarchy. Load tree. H tree manager. Load tree. Okay, let's put some information here regarding chunks. Please check what is it called? Chunk.io. Chunk.io.h. It has chunk load class, and interestingly also a chunk save class. Yeah, it certainly, if he needs to, I mean, for now, it's fine that he just reads basically binary data and dumps the binary data. That's what he basically does, right? So right now, what is happening here in his pull request, he basically, he just reads the raw data and he puts it into this chunk info thingy here with some subchunks, chunk type, chunk size. But basically this data here, it needs more information. In here, it needs like, okay, what is actually in this chunk? Like complete understanding. And we have all the understanding. It's all in Thyme, right? So this needs to be like evolve into like, yeah, what is actually in there, right? I don't know what these guys are here. Past mesh data, past emitter data. I don't know. That's strange. Begin chunk. Save class. Open chunk, close chunk. Contains chunk. I think that the chunks should be read exactly like they are read in this tool here. Here, parse subchunks. Like I think it should be parse, or here in the other example, which does the same thing. So it does the C load and then parse subchunks. What does this do? And then it writes into this chunk data thingy here. What does that do? Chunk data, chunk name, chunk info, chunk dumper, chunk data, chunk info, chunk data, chunk dumper, subchunks data, name. Yeah, I also don't have the full knowledge of this stuff. It basically needs to be understood. I think wdump and W3D viewer are good references because they give great, like they show how stuff is used over 4,000 lines of code. Most of it is probably boiler, but yeah, there's a lot of yeah, basically all W3D chunking reading is here, right? Yeah. So my expectation is that all information is in here in W3D dump, wdump. It's a lot. It is a lot. Yeah. I expect it will be a lot of work to build XML. Yeah. But okay. Okay. Well, I don't know his full plans. Maybe he is also looking at the other codes from John Bill. So I don't know. I wonder. So wdump is doing a lot of stuff here. But all this kind of logic, apart from like texting and stuff like this, it should also be happening in Thyme itself. So let's, for example, search for this one here. MachO, load W3D. Let's search for this. Let's search for this here. Chunk load. Ah, yeah, there we go. Yeah. Read channel. Yeah, there we go. Yeah, there we go. So basically all these functions that take this chunk load class, they are interpreting those chunks and doing something with it. Like, so here reads opacity keyframe. That's reading it. Yeah. Yeah. And so how much do we have here? Can we see how much lines we select? I'm not sure. But it looks like wdump probably covers all of these things. Maybe not all of them. To me, it looks like there's actually more here, down here, than there is in wdump, no? Let's, hold on, let's take a copy of this. Here, copy. Let's put it in here. So if we look at this here, we have 175 lines. 175 lines, and here we have around about 173. So yeah, it's probably the same stuff roundabout. Yeah. Let's when you search Thyme for, then you find all functions that read the chunks. Around 175. Times 2. I wonder, are there also functions that take chunk save class? Probably not. Oh, actually there are. Look at that. There are some functions that take save. Mm-hmm. Mm-hmm. There are also functions that take this, but it's incomplete. You can check with @Thompson's if Thyme is complete and the rest is simply not in retail executable. If so, then all the missing chunk save class functions need to be implemented by hand, mirroring the read functions. This will be a lot of work, but looks doable. Should be doable, but should be doable. Okay. Can check the W3D tools from Johnville if work has been done elsewhere. There was a link somewhere. Let's see, it was, I think, W3X. I don't remember where the W3X exporter of W3D importer. Let's search Google. John will W3D 3D Smacks 2023 maybe. This one, yeah. There we go. Can also check the W3D tools from John will if chunk functions have been implemented elsewhere. I wonder why there is a chunk save class in retail. Maybe it has not been cleanly compiled out, because saving W3D, like retail game does not need to save, right? So this must only be a developer functionality to export some file, right? No. Okay, well, that's all I can say for now. Basically, yeah, all the code to read the chunks from W3D is there. Then all the chunk saving needs to be implemented, and then obviously you need chunk save and load equivalents for the W3X format, right? So yeah, expect implementing 175 times 3 functions just for that, for W3D, one set for saving, and then for the XML format, 2 sets, reading and saving. So yeah, it's a lot of functions, it's a lot of code, and obviously need to be very careful that, like, when you implement this, that that everything is proper, right? That all the types are correct, and that the reads and writes are in the correct order and with the correct names, right? And checkings and whatever, right? So it requires quite a bit of attention to not make mistakes, because I think it's easy to make mistakes here. Yeah. So I don't know. Yeah, I guess for Well, for reading and writing W3D, you can just like read and then write it out and see if there's any mismatch, right? For the XML format, yeah, that's a bit more tricky because you don't have a reference. Well, you can do a round trip with XML. You load the W3D, you save the XML, you load the XML, and you convert and save to W3D, and then you binary compare the W3D again. If that is mismatching, then it means there's some error. Yeah. So you can actually test it and verify that it's all correct. Yeah. Let me also put this information here. XML format then also needs functions for those save and load functions with chunk load class, chunk save class, or equivalent. I guess it could be like a XML chunk load class. I'm not sure. It depends on what exactly is inside those classes. Let's take a look inside. Oof. Yeah, I'm not sure. Maybe there needs to be a separate class, XML chunk save class and XML chunk load class. Because this one is like binary format. And the XML, it needs to be treated differently, I guess. Yeah. It probably needs to be different, but in essence, it can be implemented similar to how it's done here for the binary format, right? Yeah, so similar approach, but obviously implementation details here will be different because it needs to write text for XML. So that will be a bit more complicated code, I think. Now. Or equivalent, let's say XML chunk load class, XML chunk save class. At the very end, when everything is done, you can test quality of load and save by loading W3D, saving W3X, loading W3X, saving W3D, and then binary compare the W3D before and after. If it is always a match, then conversion quality conversion is perfect. Yeah, I think that's the essence. Mhm. Mhm. I think it's a lot of work, especially the XML part. Yeah, but I think it's all possible without any errors. Yeah, I think all the information to work with this is there. Yeah, should be possible. Hmm. Yeah, I guess saving the XML is probably and reading the XML is probably a bit tricky because you need to have an XML parser essentially as well. Yeah. Um, I'm not sure. I mean, could also be done custom. Yeah, I'm not sure. For the XML read and write, you perhaps need a third party library to help with the formatting. Or probably you would likely help with to help with it. Yeah, because otherwise you would have to implement all the XML reading yourself, and I think that is not necessary. No, probably needs to use the XML library and then just like say, okay, what do we want to write? What do we want to load? Yeah, yeah, maybe. Good. Okay, so other than that, we still need to research. The MachO symbols. We didn't get far yet. So the next idea was to try some new libraries from GitHub to help understanding those symbols. Yeah. So there was so Inhibition wrote something about LLDB. LLDB. Software debugger. Next generation high performance debugger. Reusable components. LLVM disassembler. LLVM disassembler. What is this guy? Default debugger. Debugging. LLVM disassembler. What is this thing? LLVM disassembler. LLVM dis. Bitcode file. Assembly language. Huh. Let's ask ChatGPT. Would LLDB or LLVM disassembler be of any use to let's be specific in our language, to interpret, to analyze to analyze MachO symbols, to analyze let's see. Yes, both LLDB and LLVM disassembler can be useful for analyzing MachO symbols, but their usefulness depends on the depth of analysis. Here's a breakdown. LLDB is primarily a debugger, but it has features that can assist in analyzing MachO symbols, particularly in a dynamic or semi-static context. What is semi-static? LLDB can list all symbols in a MachO binary using commands like image dump symtab. Okay. This provides a detailed list of symbols, including functions. Okay. If the MachO is executable, LLDB can dynamically resolve and display symbol relationships during runtime. Virtual function calls can be traced back to their vtables through dynamic inspection. Virtual function calls. Okay. If partial RTT information is embedded in a binary, LLDB can display and interpret it to some extent using target variable or frame variable. Using to map addresses to symbols and understand their usage. Okay, that's unfortunate. Okay, we already did this, I think. Disassemble MachO sections to see how symbols are used. Okay, that's not good. Manual effort. Okay. So this doesn't give us what we want. Trace vtables at runtime. High-level concept like inheritance, hierarchies, or class structures require manual reconstruction or additional tooling. Okay, so it looks like both these tools are not what we really want. Okay, so options we have right now is this here, which is kind of abandoned. This one and this. Yeah. Up to 1/4. And the features read really nice. The question is, will it be easy to use? Visual Studio 2017. Okay, how about we take a look at the code a little bit to see like what is in there. It uses capstone. Huh. There's a lot of stuff in here. RTTI Finder. GCC parser. Okay, right now I don't understand what's going on here. It's really not much. 2 functions in here. That's not much. RTTI Finder. Loader image. Get V2. Let's take a look at this tool here. Decompiler. Oof. Get param or die. Okay. Oh no, they use STD lists. Oh boy. Oh boy. Jesus Christ. Afterload. Oof. MachO extractor. So, what kind of options are here? Okay, so you can output a file. Output modes, PDB. Input file to decompile, output, yeah, backend arguments, hmm. Okay, so my suggested approach here would be to simply test this decompiler and see what it generates. Does it open a UI, or what does it actually do? Let me see. Does it just create like a text file as output? Okay, so how about we take this guy. Or we just download a precompiled one for testing. Right, maybe that's good enough. Here, Windows release. Yeah, let's do that. Windows release, yeah. And then we see what it gives us, and if it's any good, then we can dive in deeper. Otherwise, if it just produces trash, then there's no need to continue looking, right? If the command line tool doesn't even give us anything good, then yeah, we won't be able to do anything with it. No. Okay, so we have this. Then I will simply Oof, there's a lot of files in there. Yeah, then let's take this projects assembly armada misc, put it in here and extract to this. Okay, then we can delete this one here. How big is this? Wow, 1.5 gigabytes. Holy shit. What is in there? Jesus Christ. Okay, but this is not that big here. 134? What is so big? Lib? 300? Share? 1 gigabyte. Whoa. What is that? What is so big here? Ordinals? What the hell is that? Huh? What is so big here? I don't get it. What is in here? Huh? Static codes. 1 gigabyte. Elf. What is that? Huh? Huh? P. Patterns. Patterns. I don't understand. What are these patterns for? Let's take a look in there. Huh, some binary file. Strange. Maybe it's some metadata that is used by the tools. I don't know. To do something. I don't know. Okay, let's run. What do we run? There are multiple tools. What is this here? Okay. There's a demangler, decompiler, bin to pads, MachO extractor. Okay, let's open command line. And let's go here, data. Let's open this path, cd, this one, and then we run this. Let's try this one here. I want to see what this does. That. Okay. Usage options file. Extract all objects from binary. Okay. Okay, let's create a. Let's create a subfolder here. Tests. And we put this in here. Extraction best name, family index. Okay, let's do cd tests. Yeah. And then we do zh, no, options file, all, minus all, zh. Uh-huh. Uh-huh. Okay, interesting. So that's this portion and the other portion. Okay, and now if we do zh dot I 386 the file is not a valid MachO universal binary. Huh, okay. 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 Okay, what else can we do? Pet to Yara. MachO extractor. Good. File info. Let's try this one. File info. .exe. What does this do? Plain text. Plain. Okay, let's just use default. So we say this and then ZH. Okay. Let's output this to a file. So this is reddeck minus file info.txt. Okay. All right. Xcode detected tool. Xcode with OS X SDK or higher. Nibbles compiler. Entry point name text. Little endian. Information about symbols is shown for just one architecture. Huh. Okay. Okay. Exact. Pass. Oh, you can't specify any architecture here. I don't know. Okay, I don't know if there's more we can get out of that. Okay, let's try this decompiler. Let's see what that does. So let's remove this. Reddeck decompiler. There we go. Input file not set, yes. Let's see, minus minus help. I think we just run it with default options, right? Clean up. Let's see. Ah, here you can architecture. Okay. Then let's see just what happens. ZH. There we go. Okay. Seems to be a more costly process. Okay. Okay. Okay, so it does. What is this? Okay, so it has generated this file here. And it's still doing something. So I guess we just need to wait. Yeah. Well, it looks like this is that. It has extracted this portion here, right? Maybe it's just a temporary file, I don't know. Okay, address spaces, optimization, FPU register analysis, main function identification, libgc idioms, VM instruction optimization, conditional branch optimization. I don't know what all this does, but it is busy, so it's doing something. Yeah. I am not surprised that it is so slow, because when I looked at just a few functions in there, I saw std sets and std list inside functions, passed as arguments, and oof, maybe there's some very heavy, costly implementations that are more expensive than they should be. Or maybe it's just doing a lot of stuff. That could also be. Constants optimization. It is slow. It's probably also single-threaded only. Yeah. It didn't create any files other than this yet. Output default plain. Output format is plain. Input file. Output format plain JSON, JSON human, default plain. So I guess it will create a ZH something. ZH something. Maybe it will overwrite this ZH because it doesn't have an extension. Let's see. Okay, things are slow. Very slow. Let's make this larger. I wonder what it actually does. What would it actually generate? I don't know. So we just have to wait and see. Yeah. Yeah, I don't know how long this will take here. Maybe it would take hours. Which would be worrying. Okay, what other tools do we have here? Demangler. Okay, that's interesting. AR extractor. There's many issues here. My expectation is that it does more than we actually need. It probably tries to disassemble all the functions or the assembler instructions. But we don't want that. We only want to we only want we only want the V tables and type infos, and yeah, we want to know what is class and function and so on. Maybe the disassembler is not the right tool. Maybe there's another tool. Unpacker. Now we can test more. We can also try this executable. I wonder what this does. Maybe we open another command prompt. cd test. And we go here. Bin red stack help input file reddeck.exe zh -e. What would that do? Does nothing. I don't know if it does anything here, but It's not saying anything. Let's cancel. Okay, what else do we have here? AR extractor. AR extractor. AR extractor.exe help. What does this do? Arc magic. -EZH. File too small to be an archive. Okay. Okay. Okay, what else do we have here? What is capstone? Capstone. Capstone to llvmir.exe. Help. What does that do? Set architecture name, base address, binary data. Okay, let's just give it a try. I guess just pass that H. No. Huh? Okay, it's you have to pass like code or assembler here, I see. Okay. It's nothing for us then. I wonder if the decompiler is calling this some way. Maybe. Yeah, okay, what does a demangler do? Demangler.exe. We can let's see what it does when we, let's see, here. Let's search for a .f here. Let's see what it says about this one here. Oh, this one has finished. Nice. Okay, let's test demangler and then this string. No? Mangled name. Well, that didn't work. Aha, that worked. So it doesn't work when there's this thing at the end. Okay. Okay. Okay, so this has finished here. Let's see what it generated. Tests. It generated a BC file, a C file, a config, and a DSM file, and a LL file, and this one here, extracted M. Well, let's take a look at these guys. Okay, this is a binary file. No idea what that is. Next. Okay. Switch to Game Ranger. That's weird. Huh. Well, 10,000 lines of code don't cut it. That's not much. I wonder why I just try to disassemble so few. That's weird. Okay, what is this? Config.json. Oh boy, this file is slow. Oh boy, forget it. Okay, let's take a look at this one here. Huh, disassembler. Oh, it's also very little code, no? So I do wonder, does this, if we look for some CPP file here, how .cpp, let me see. So this address, is this referenced anywhere then? Huh. That's weird. Maybe for asserts that could be. Yeah. It could be calling a assert here or something. Maybe. Mm-hmm. Mm-hmm. This explains why there are multiple strings or references to the string. Yeah. Mm-hmm. Mm-hmm. Okay, what is this file here? Constant. Global. Unnamed. Hmm. 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 Jesus Christ. Hmm. I'm surprised though that these things are unknown. Why are they just saying local unnamed, global, local unnamed, global var? Hmm. Hmm. I was expecting more names here for these global variables. Hmm. That's a bit surprising. Hmm. Okay, I think I will take a break here. Let's take a look next session a little bit more into this. Yeah. Good. I wish you a great day or night. Until next time. Goodbye.